Unit 2B, Lesson 1, Introduction to Slope. What you should know by the end of this lesson. First, you will learn how to identify slope and the y-intercept from an equation and also from a graph. You will also learn to create an equation in slope-intercept form if you are given a graph, or if you're given the slope and a y-intercept, you can also write an equation. Here are our notes, and we're going to start with some basic vocabulary. So this lesson is about learning slope, and the form that we are going to start with for writing slope is called slope-intercept form. As you can see here, it is our most user-friendly formula for linear equations. And we like slope-intercept form because it allows us to easily graph without having to make an X and Y table, because that's a lot of extra work. And if the equation is already in slope-intercept form, we can see everything that we need to go ahead and graph the equation, and we know what it will look like. So let's first start by breaking down the slope-intercept form. So the formula for slope-intercept form is y equals mx plus b. Y equals mx plus b. All right, so there's a couple of components here that we need to talk about. First off, we have our y and our x. These are going to change depending on input and output for our equation, and they typically stay variables unless you are doing the x and y table. So the x and y stay variables. The m and the b are the parts that we are looking for today and learning about. So let's start with the m. Notice that it is directly in front of x, which means m is being multiplied by x. It's also known as the coefficient of x. But most importantly, we call m the slope. It is always located in front of x because it is the coefficient of x. This tells us a lot of things about our line. It tells us the steepness, it tells us the direction of the line, and it also helps us to graph the line if we're creating it. The next part is this plus b, and this is known as the y-intercept. It's always a constant that comes after x. So often it's a whole number. It could be a decimal or a fraction, but for example, it could be plus 2 or plus 5 or plus 10. It can also be negative, and in that case, it's not always a plus b. It might be minus 5 or minus 10 if it's a negative y-intercept. So knowing that the slope goes in front of x and knowing that the y-intercept comes after b, let's identify in this example A the slope m and the b. So the equation is y equals negative 2/3 x plus 4. First, we want to find m. Well, m is the coefficient of x. It's located. So find the x, and in front, we have this fraction, 2/3, and we also have this negative sign. So that negative sign belongs to the 2/3. So the slope of this equation is negative 2/3. All right, now let's find the y-intercept. It's always after the x, so we have our plus 4. So b, the y-intercept, is a positive 4. All right, let's learn a little bit more about the m and the b in our equation. So this slope, the number in front of x, it's also known as rise over run of a linear equation. We use it as rise over run when we are graphing, which we will do in just a little bit. The variable that represents slope in the linear equation is m. So when you're writing what is slope, you're always going to put m equals. That's just the letter that is for slope. And then also, slope is also known as the constant rate of change. So anytime that we are talking about a constant rate of change, that's the slope. Anytime we're talking about that's the slope. Anytime we say rise over run, that's the slope. The coefficient of x, that's the slope. So we have lots of different words that we use when we're talking about slope. All right, the y-intercept is where the equation crosses the y-axis. So this is the number where we put our point on the y-axis and where our line is going to cross the y-axis at. The variable that represents the y-intercept in a linear equation is the letter b. That's why it comes at the end. And this kind of helps you. It's the beginning point when we go to graph. So you always use your y-intercept as your starting point, your beginning point when we go to graph. In this next section, we're going to identify the slope of the equations written in slope-intercept form. So let's do this first one together. Y equals 3x plus 1. Starting out pretty easy. Remember our formula is y equals mx plus b, where m is your slope and b is your y-intercept. So the number in front of x is 3. That is our slope. And b, the constant after x, is a positive 1. Let's do the next one. Y equals negative 1/3 x plus 2. So this time, the coefficient of x is negative 1/3. And our y-intercept would be a positive 2. Make sure you always take that sign in front. Example 3, y equals 1/2 x minus 4. So our m, the coefficient of x, would be 1/2. So m equals 1/2. And our y-intercept this time is a negative 4 because our equation says minus 4. So that sign belongs to the 4, and we know that that is where the graph will cross the y-axis. All right, example 4 is a little bit tricky, but not really. Y equals x. So we are looking for the number in front of x and also the number after x. So remember this year when we have talked a little bit about invisible math. There is a number in front of this x, but we don't write it in algebra because it's just understood to be there. So how many x's are there here? Well, there's 1. There's 1 x. And we don't typically write that 1, but it's understood to be there. So in this equation, y equals x, the number in front would be 1. This has a slope of 1. Now we also want to look for what's after the x, and there's nothing there. So in algebra, what represents nothing? Well, that would be just 0 plus 0. So our y-intercept is 0, which means that this graph of the line is going to go through 0, 0. Example 5, y equals negative x plus 9. So in this case, draw my little arrows. We have a negative sign in front of x as the coefficient. So what number would that represent? It's not just negative, but it's negative what? Negative 1. And then our y-intercept is a positive 9. In this next section, we're going to learn the 4 different types of slope. The first type of slope is what we call positive. It shows a line that is moving uphill from left to right. And when we're reading graphs, we start on the left side and move to the right, just as if you were reading a book or a page or anything. You start on the left and move right. So as we go from left to right, this graph is going uphill. So we know that that is a positive slope. Example 2, as we move from left to right, this graph is going down. And this is what we call negative slope. The third example is a horizontal line. And it has a 0 slope. It is perfectly flat. There's not any hill where this is going uphill, this is going downhill. There isn't a hill. So this is like the floor in the schools and buildings. It's perfectly level. There is no slope at all. It's like what you would like to skate on, because there isn't any hill that you would have to climb or go down. So it's perfectly flat. And the fourth kind is our vertical line. Okay. And this one is what we call undefined slope because it is perfectly vertical. We would be unable to walk up this line due to gravity. It's undefined. This would be the easiest to walk because there's no slope. Or you could argue that the negative slope would be easy because you would be going downhill. And the positive is going uphill, so it would probably be the hardest. And it depends on how steep. So we're going to look at some positive and negative slopes that aren't quite as steep or even steeper than these. On this next section of your notes, you're just going to go through and look at each of these different lines for examples 6, 7, and 8, 9, 10, and 11, and tell me which of the 4 types of slope you see in the graph. So you can pause the video and write whichever one they are, and then press play to check your answers. Example 6, as we move from left to right across this graph, it is going downhill, so this would be an example of negative slope. Example 7, as we move from left to right across the graph, this is also going downhill. So this is another negative slope example. This one you can see, they're both negative. This one's pretty steep, number 6, but example 7 is not near as steep. Example 8, as you move across the graph from left to right, this one is going uphill, so that means that it is a positive slope. Example 9, this one is our vertical line, and it has an undefined slope. Example 10 is our horizontal line, and a horizontal line has 0 slope. It has none. It's perfectly flat. The last example, 11, is going downhill as we move left to right, so that would be a negative slope. I hope you got all of those correct. Now we're going to take what we've learned about slope and we're going to identify these parts on a graphed line and use it to write an equation in slope-intercept form. So let's break it down piece by piece. In example 12, we can tell that as we move left to right, the graph, the line goes uphill, so it has a positive slope. We first want to identify our M and our B. I like to always start with B because it's the easiest to find. So remember that B is your y-intercept. I always put y-int for shorthand, but that means y-intercept. So that is going to be on your y-axis. The y-axis is the one that goes up and down. So go find your y-axis. Go up it until you can find where your line crosses. And it crosses right here between 2 and 4, so it would be positive 3. This red line crosses the y-axis at positive 3. So our y-intercept is 3. Next, we need to find our slope. And to find our slope on a graph, we have to use rise over run. Rise over run. So this is where the points come into play. So as you notice, I already have the points identified on your papers. It might be a little hard to tell in the copies, so you have to look closely. But sometimes I go in and I just darken them a little bit so I can see. And what we're doing is we're counting how many times we have to go rise and then run to get from one point to the other. All right, so we started our y-intercept, and the first thing we want to do is rise. How many blocks do we have to rise to get to this point? Well, we would have to go up 1, 2. We have to go up 2 blocks. So rise 2. And then how many do we need to go to the right to get to this point? We would go 1. So rise 2, run 1. Up 2, right 1. And then I like to always do it one more time just to make sure I didn't miscount. Rise 2, run 1. Up 2, right 1. And it worked. So our slope, rise 2, run 1, would be 2 over 1. Rise 2, run 1. Up 2 over 1. And then we can simplify 2 over 1 equals 2. Now we have everything we need to go ahead and write this in our equation slope-intercept form. So let's start with our formula. Y equals mx plus b. So we're going to take the values we found, we're going to plug in the m, and we're going to plug in the b. So our equation starts with y equals m. What did we find m is? It's the number 2. Then we insert our x. And then our y-intercept is a 3. And what kind of 3 is it? It's a positive, so we put plus 3. And we just wrote the equation for this line. Let's do some more. Example 13. We're first going to locate our y-intercept. Always first find your B. So follow your y-axis until you reach where the line crosses the y-axis. And this one crosses right here at -2. So B is -2 in this example. Next, we're going to count from this point to the one on the right. You always go from left to right. I know there's a point down here, but if we start here and count, and then we could go. But you don't go left, you always go to the right. So I like to start at my y-intercept, and I'm going to count my rise first. So I'm going to go up 1, 2, 3 units, and then run to the right 1, 2. So we went up 3, right 2. Let's try and see if that works. Up 1, 2, 3, right 1, 2. Be sure you're doing this on your paper. So rise 3, run 2. Our slope is 3 over 2. Now we're going to write it in our equation. Our formula is y equals mx plus b. So we're going to start with y equals. Our m was 3 over 2. We insert our variable x. And then this time our b is negative 2. So we don't write plus negative 2. We just put minus 2. And there is our equation. Example 14. Let's start by finding our y-intercept, our b. Follow your y-axis until you find where the line crosses. And it crosses between 2 and 4. So that would be a positive 3. So b is positive 3. If you want to put the plus sign, you can. Now we need to do our rise over run to find how steep this line is. So we're going from this point, our y-axis, to this one on the right-hand side. So how many do we need to go up to get to it? Well, we go up 1 unit. So our rise is 1. Now we're going to go to the right, and we got to carefully count. So there's 1 block, 2 blocks, 3, 4, 5. So rise 1, run 5. Let's check it and do one more to make sure. Up 1, right 1, 2, 3, 4, 5, and it works. So rise 1, run 5. You always have to put your up on top, how many you went up, and how many that you went to the right on the bottom. Okay? Okay, let's write our equation. Y equals mx plus b. So our equation starts with variable x, y equals m. We got 1/5. Variable x. And our b was a positive 3. So our equation is y equals 1/5 x plus 3. Number 15, we're now going to do our first slope that is not going uphill, but this one is going downhill. So this one is a negative slope. This is our first example of a negative slope. So here we go. We're going to always start finding our y-intercept, our b. So follow that y-axis up until you get to the point where the line crosses. This one crosses between positive 6 and positive 8, so it is a positive 7. Now we need to count our distance from this point to the next one on the right. Now, these are points, but see how they're not at intersections? They're like little fractions, so you can't tell what they are. That's why you have to go all the way to the next point that is at an intersection. So we're going to go from here to here. So normally we rise, but this line isn't going uphill. This line's going downhill. So when we rise for a negative slope, you're going to be going downward. So how many blocks do we need to go down so that we're even with this point? We go down 1 block. So that means negative 1 would be our rise. Now we still go to the right just like we did before. So we're going to count how many blocks we have to go right to reach this point. Count carefully. 1, 2, 3, 4. And then do it again just to check it. Down 1, right 1, 2, 3, 4. Down 1, right 4. And if you want to write it over here to help you, that also works. So down 1, right 4. So the slope is negative 1/4. And so this time we know that it's not always up over right, but it could also be down over to the right when you're counting. So up or down, depending if it's positive or negative, and always to the right. Okay, so let's write our equation. Our formula, y equals mx plus b. So we're going to start with our variable y equals. Our m is negative 1/4. variable x, and our y-intercept is a positive 7. So there you have it. The equation for this line is y equals negative 1/4 x plus 7. Number 16, we have another negative slope. So let's start by finding our b. We'll follow the y-axis up, and we reach the intersection of the y-axis and the line right here at positive 1. So b is positive 1. Now we're going to go from this point to the next one on the right. So that would be over here. Okay, we're going to ignore this point up here. We're going to go always left to right. So we're going to have to go down again since it's negative to reach this point. So how many blocks do we go down? We go down 1, we're at 0. We go down 1 more, 2. So down 2, and now we're even with it. So the rise would be down 2, which the number that represents that is negative 2. Now, how many do we need to go to the right to reach it? Well, we only have to go over 1 to the right. So let's simplify that. Down 2, right 1 simplifies. Negative 2 over 1 would just be negative 2. Anything over 1 is just itself. So now let's put that in our equation. Our formula is y equals mx plus b. So we start with our variable y equals. Now next comes our m. What did we find for m? Negative 2. Variable x. And then last is our y-intercept, b. So we found positive 1. The equation for this line that is being graphed, or is graphed, y equals negative 2x plus 1. Example 17. Start with finding your y-intercept. Follow your y-axis up until you reach where the line intercepts the y-axis. And this time it crosses perfectly right here at 0, 0. So our b is just 0. Now we need to find the slope. So we're going to look to the right until we find our first point, which would be right here. It is going downhill, so we know it's going to be negative. So that means we're not going to have to go up to get to this point. We're going to be going down to get to this point. Negative slope means you're going to be going down. So how many blocks do we need to go down so that we're parallel with this one? So we're going to go down 1, 2, down 2. So what number would represent that? Negative 2. Down 2. Now we count how many we have to go to the right until we're at that point. So we count carefully. 1, 2, 3, 4, 5. So down 2, right 5. And let's check it by going to this next point all the way over here. Down 1, 2, right 1, 2, 3, 4, 5. And it worked. So our slope is negative 2/5. We're ready to write our equation. Here's our formula, y equals mx plus b. So we start with y equals negative 2/5 x. And then our b would be plus 0. But since this is algebra, do we ever write plus 0? No, we just know that it's there. So that would tell you when you see this equation, y equals negative 2/5 x, that the y-intercept is 0 and that this line graphed is going to go through 0, 0. Okay, this next one, number 18, you may notice is our horizontal line. So what kind of slope did we say our horizontal line has? It's perfectly flat. How many do you have to go up or down to reach the next point? Well, you don't. So we automatically always know that a horizontal line doesn't have a slope. It's perfectly flat, so the slope is 0. It does have a y-intercept, though. Follow that y-axis up, and it crosses right here between negative 6 and negative 4. So that would be what number? Negative 5 would be the y-intercept. All right, so now we want to plug this into our equation. Remember our formula, y equals mx plus b. So if we plug this in, we start with our y equals mx. What did we get for m? We got a 0, x, and then our b is minus 5. So we don't want to put plus, we want to put minus 5. All right, now this looks funny because we don't have all this in algebra. There's a lot of things that can be simplified here. First of all, anything multiplied by 0 is 0. So what's going to happen right here when we do 0 times x? Well, that's just going to be 0 minus 5, okay? This becomes 0. All right, and then we can do 0 minus 5. We just end up with y equals negative 5. So anytime that you have a horizontal line there and there is no slope, it's just going to be y equals whatever number it crosses the y-axis at. So this graph crossed at negative 5, so the equation is just y equals negative 5. There is no x in this equation because it never crosses the x-axis. It only crosses the y-axis at negative 5. Example 19. For this one, we have it going downhill, so we know it's a negative slope. Let's go ahead and find our y-intercept. Follow the y-axis up until we reach the line of intersection, and it is at, it looks like positive 6. Now we're going to count our rise and run to the next point. It is a negative, so we're going to go down 1. What number represents that? Negative 1. And right 1. Down 1, right 1. Down 1, right 1. So that would be down 1, right 1. Negative 1 over 1. So what does that simplify to? Well, that simplifies to a negative 1. What's negative 1 divided by 1? Just negative 1. So now let's write that in our equation. Our formula, y equals mx plus b. Y equals, what did we get for m? Negative 1. X, and what do we get for B? Positive 6. Now there's also something here that we don't typically write in algebra. That's that negative 1. We normally just leave it just the sign. So this is correct and is acceptable if you write that, but truly simplified all the way, we would write it as y equals negative x plus 6. And this is what I would like for you to be able to get to. It is equal to this one, but typically we don't put that 1. All right, number 20, this one is our vertical line. What kind of slope did we say our vertical line has? It has an undefined slope. All right, let's find our B. Follow that y-axis up. Where does it cross the y-axis? This red line never crosses this y-axis, so there isn't one. None. It doesn't exist. All right, so let's think about our formula here. Y equals mx plus b. Well, it never crossed the y-axis, so we know we're not going to have a y in our equation. What did it cross? It crossed one of the axes. Which one? It crossed our x-axis. What number does this cross our x-axis at? Oh, it crosses right here at let's see, negative 4, negative 5, negative 6. So it crosses x at negative 6. So the equation for this one is just x equals negative 6. Because the only thing this line does, it doesn't have a slope. It only crosses x at negative 6. So that would be its equation. All right, the next part is your practice. There's 6 problems. You're going to do exactly what I just did with you. You're going to locate your y-intercept first. Then you're going to count your slope, your rise over run from one point to the next. Always move to the right. And then put it in an equation, y equals mx plus b. And there are 6 of these problems, I do believe. Remember, if we go uphill for 1, let's see, 2 is negative, so going downhill. Don't let that one trick you up. Look back at your examples if you need help. 3 is uphill, 4 is uphill, 5 is uphill, and so is number 6. 6 is going downhill, so that's a negative slope. All right, so try these. Look back at your examples to help you.